Commission. He earned a PhD in history from the University of California at Berkeley. He's published several books, all of which are pertinent to the subject of this panel. One was called Critical Masses, Opposition to Nuclear Power in California. Another called Preserving the Nation, the Conservation and Environmental Movements from 1870 to 2000. Previously, he was a professor of history at Central Washington University. He also worked as a systems engineer at the Davis-Besse Nuclear Power Station and as a reactor test engineer for General Dynamics. He's authored quite a few articles, which I'm sure he'll be discussing today. And Tom's most recent book is especially pertinent to this session. It's called Safe Enough, ? The History of Nuclear Power and Accident Risk, which was published by UC Press this year. I'll turn the microphone over to you, Tom, for your presentation.
Thank you, Ahmed. I'll get my slides up. Okay, I assume you can see them?
Yes.
Okay, great. All right. In our pre-meeting, I was asked to kind of offer broad generalizations about the strategies of public engagement that the industry and nuclear regulators pursued since the 1950s and the beginning of the first commercial nuclear power era. And I think there's three distinctive eras that are really kind of characterized by assumptions about public trust, how the public would trust the messages that were put forward by the regulators and the industry. And in the first era was pretty simple. It was, the industry essentially operated on the assumption that the public trusted experts and were willing to be educated by them. There was and this was logical, since the AEC and the nuclear industry was highly respected in the 1950s. But as time moved on into the 1960s and greater criticism arose, questions about expertise and their alliances, the AEC concluded that the problem was one of messaging, and that the public would perhaps trust more objectively stated proofs of safety, essentially a trust in numbers that with quantitatively expressed measures of accident risk, you could compare nuclear power's relative hazards to other kinds of technological activities that the public engaged in all the time. That approach also had its problems. And really, after the 3 Mile Island accident and the decline of the era of plant licensing, the NRC and the industry kind of pull back, I think, from a kind of proactive public campaign or education effort and turn to a kind of more modest effort to essentially earn back trust through competent regulatory operations and high-level operational performance by the industry. So let me turn first to the first era, trust the experts, which I kind of characterize as being between 1955 and about 1971. Of course, the Atomic Energy Commission had two, kind of conflicting roles. It was supposed to promote nuclear energy and its uses, as well as ensure reactor safety, the topic of today's conversation. So they were certainly expected to promote nuclear energy. And they did this in a number of ways, of course, to talk about the possible uses of nuclear energy, but also through literature campaigns, also stress how safe nuclear power was, as this brochure from 1964 indicates. Now, what they tried to do in this early period is they tried to keep it simple. They tried to argue that atomic safety was really quite simple. There were two kind of key components to reactor safety. The first was to design reactors that could not explode or have power excursions that would suddenly release energy through various kind of reactivity accidents. And the other, you can see on the cover of this pamphlet, that basically that containment building, that containment dome, and conservative design would essentially take care of every other kind of maximum credible accident, any other kind of mishap. Now, that approach was pretty simple, right? Two basic concepts. It was not hard to imagine why reactors were safe. But ultimately, that is going to be undone, and I'll get into that in a second. Before I do, I want to mention one other thing. The other way that the Atomic Energy Commission interacted with the public back in the 1950s was kind of unexpected. Licensing, oddly enough. It wasn't clear how much public participation they were going to get. And originally, there was no requirement that you hold a public hearing to issue a construction permit until the Fermi 1 liquid metal fast breeder reactor near Detroit was proposed, and the AEC issued a construction permit. And only after they issued the permit did the public become aware that the Advisory Committee for Reactor Safeguards had issued a letter that was critical of the design, said that more testing needed to be done. There was something of a public outcry that occurred because of this. The controversy essentially results in changes to the Atomic Energy Act of 1954. 1957 legislation, essentially two key components here. Hearings are required for all construction permit applications, and ACRS evaluations would be made public. And it's clear that many more documents are going to be made public through this process than had been imagined. Now, the politicians who pushed through the legislation that came through in 1957 were pro-nuclear. What did they imagine that they were doing? And the idea is that through the hearings process, experts would educate the public, that that this would be essentially a reassuring process, and the public would listen to the experts and be reassured that the plants located in their particular community would be safe enough. So that was the intention of the licensing process, but that comes in for trouble as well. Okay, now largely because what you find through the 10 CFR Part 50 review process of issuing a construction permit and operating license is that there were regulatory surprises often during the review process. As they scale up power plants, the Advisory Committee for Reactor Safeguards comes to an unpleasant conclusion in 1965 through 1967, that there was enough energy in those plants to lead to a core meltdown during a loss of coolant accident, one of these maximum credible accidents, and that it could actually break through containment. So that final barrier that they had emphasized as, creating the simplicity of safety was really problematic. As Alvin Weinberg, he was a longtime director of Oak Ridge National Laboratory, put it, he said, really the China syndrome debate that ensued because of this realization had profound repercussions. He said, the AC was able to argue that with containment, the consequences of even the worst accident was zero. But now we had to argue that yes, a severe accident was possible, but the probability of it happening was so small that reactors must still be regarded as safe. Otherwise put, reactor safety became probabilistic, not deterministic. This, of course, creates a great deal of problems, not only in the design and regulation of reactors, but also in talking to the public. Experts in the public really begin to have great difficulties in the late 1960s. When experts go out and try to debate critics in public, basically, it didn't go well. Tommy Thompson, who was one of the commissioners on the Atomic Energy Commission, after one of these sponsored debates with experts in the AEC, declared that the experience was an utter disaster. Basically, experts found that talking about low probability, high consequence events was an extremely difficult thing to do and for the public to grasp. And so in these debates, they often found they weren't doing well. Now, one of the solutions that's put forward by Chauncey Starr, who was the Dean of Engineering at UCLA and later one of the founding people of EPRI in the industry, he argued that essentially it's a messaging issue, that experts had basically created a generation of nuclear hypochondriacs with confusing language about reactor safety. And his solution was to quantify risk. Quantify the risk of a major accident and then compare it to other technologies that people experience in their lives every day. The AEC picks up on this idea and comes up with the first major the first major probabilistic risk assessment, WASH 1400, which is put out in 1975. They put out in the executive summary comparisons, direct comparisons of the risk that was calculated in WASH 1400 for nuclear power accidents with other kinds of accidents. Here you can see airplane crashes, fires, dam failures, and the like. Now, this approach was problematic for two key reasons. One is that what social scientists would later find is that the public was not particularly persuaded by numbers themselves. They had a much more complex view of risk than could be summarized in these kinds of simplistic, graphs of risk and safety. The other problem was that WASH 1400 itself was a flawed messenger. The study had major problems as far as uncertainties and potential error bands with its estimates. And making these kinds of comparisons of nuclear risk to other kinds of well-known risks was inappropriate. So for the AEC, they really are adrift in the 1970s. There's really not a good strategy about where to go forward. For a number of reasons, they find that they're being undermined not only in these debates about safety, but also in the licensing proceedings that were supposed to educate the public. Basically, what they find is that, at least in some cases, the licensing hearing process was not a story of nuclear experts educating the public, but ultimately interveners educating the public instead. The best example of this is the Shoreham hearings, the construction permit hearings that were held in the early 1970s. Instead of the usual 2-week hearings process that most plants went through, Shoreham hearings took 2.5 years. The interveners were well financed. They had an excellent lawyer, experts galore, who they put on the stand and testified about their concerns about nuclear safety. And not surprisingly, over time, the public on Long Island, especially, the cry that you can't evacuate Long Island, began to ring true. And you find that politicians at the local level and at the state level begin to turn against the plant. And of course, over time, in a major way, begin to intervene in the proceedings. And ultimately, the plant does not operate and produce electricity. The AEC was also being questioned for another key reason. Its environmental responsibilities under the National Environmental Policy Act. In the Calvert Cliffs decision of 1971, the DC Circuit Court had heavily criticized the AEC, so much so about its unwillingness to seem to take its environmental responsibilities seriously, that the AEC essentially starts to pull back from this idea that it should promote nuclear power. James Schlesinger was the chairman of the Atomic Energy Commission in 1971 after the Calvert Cliffs decision. And in a kind of well-known speech before the nuclear industry, he said to them, from its inception, the AEC has fostered and protected the nuclear industry. You should not expect the AEC to fight the industry's political, social, and commercial battles. The AEC exists to serve the public interest. Now, that's all well and good, but what did that mean for public engagement? When the AEC is broken up under legislation in 1974 and the NRC starts operations in 1975, what kind of engagement do you expect for an independent regulator? They're not supposed to promote, but how do they engage the public? How do they explain to the public why they think reactors are safe? And for the NRC, this was really a difficult period. I can't say that they have a strategy early on. If you talk too much about why you think reactors safe, you can be seen as being a public promoter of nuclear power, exactly what they're not supposed to do. So efforts to engage critics in this period really kind of results in kind of unsatisfactory results. Okay, one other thing I want to mention too here is that the 1970s is also characterized, as I describe it, as strategies of disengagement. We're talking about strategies of engagement. But one of the options available to people who were opposed to nuclear power was to simply stop talking to the experts at the national level, whether it's the industry or the NRC or AEC at the time, and instead turn to the state level and erect barriers that way. Lots of states developed siting agencies, coastal commissions, energy commissions, and the like. And in a number of cases, those commissions essentially refuse to essentially sanction or license or give certifications to build nuclear power plants. These power plants, never make it to the Nuclear Regulatory Commission. I also want to point out in the period of the 1970s, a lot of activists turned to basically the voters to stop nuclear power plants. I can think of at least 6 examples where basically specific nuclear power plants were placed on the ballot. And interestingly enough, all of them lost. In this case, the image that I show here on the slide was the Westinghouse concept of developing a floating reactor. It was going to be anchored off the coast of Atlantic City. Atlantic County in New Jersey voted against this concept 2-1 in 1974. So ultimately, I mean, if you've got a proposal and it winds up on the ballot, you're in trouble. So what you can see here is that in many ways, there was another level of action that did not involve a conversation between the experts and the public, that they could seek out other ways of stopping nuclear power plants if they didn't like the results. Okay, the final era that I'll talk about is essentially after 3 Mile Island, after the decline of the first era of licensing that occurs. Both the industry and the NRC are embarrassed, of course, by their performance up through 3 Mile Island. And ultimately, I think what you see is that there's a strategy that's pursued in this era of essentially earning back trust. As Lando Zek, who was the chairman of the NRC in the 1980s, basically put it as, the public will come to accept and believe in nuclear power when we demonstrate our competence, and the industry does as well. And so I think that in many ways what you see is that the NRC has the messaging that you see that goes on to this day is that the NRC tries to demonstrate its competence, its integrity, its believability as a regulator. And so when it developed its principles of good regulation in 1991, you kind of see this emphasis that that the NRC is going to be reliable, it's going to be independent, it's going to be open to all views. This is the message that the agency has tried to put forward as it engages the public. For the commercial industry, I think there's a somewhat similar emphasis on competence, but of course they have to also emphasize that they can be both efficient and safe in their operations at the same time. These are graphs put forward by the NEI that they often show. And as you can see here, there's an emphasis on rising efficiency capacity factors in nuclear plant operations in the upper graph. And then in the lower one, they're trying to show that they believe that their reactors are operating much more safely than they did back in 1992, where this graph starts. So you can see this kind of evolution in the messaging that, in trying to win back trust. The message from the industry is that, that we have now this long history of safe operations, and that this, is creating a climate that we can be trusted with a nuclear energy future as well. And also in that process, that perhaps the people will trust the experts again, and perhaps our risk-informed numbers will also be a satisfactory measure. That, of course, is the hope that the industry, is arguing in, for future reactors. Okay, that completes my presentation.
Thank you very much, Tom, for that. Now we're going to move to our second panelist, Spencer Weert. Spencer received a BA in physics from Cornell University and a PhD in physics and astrophysics